Hello and welcome to Casual Learning. I'm your host, John Bannon. So, what's the deal with superdeterminism? Superdeterminism is probably one of the most important things that you could know. And I don't say that lightly. So, what does it mean? Superdeterminism means that everything that happens in the history of the universe is predetermined. What that means is that everything that happens in the universe, everything that happens to you in your life, everything that you ever do, think, feel, say, every interaction that ever occurs in the entire universe, from the greatest scales among galaxies and stars to the smallest scales, like photons or neutrinos, it's all predetermined. It all will occur exactly the way it is supposed to occur based on the initial correlations established at the Big Bang. And you can't change it. The future is unchangeable, it's predetermined. You don't know what it is, but the universe does, and it's going to follow that script. And there's nothing you can do about it. So that's a pretty important thing to understand. The universe is not random. The universe, in some instances, may appear random, but the truth is, it's not. It's all predetermined. It's a predetermined appearance of randomness, not actual randomness. The universe is superdeterministic. You may hear people say that the universe is random. They may say, well, the universe is chaotic and random and order comes from chaos. And none of that is true. That's all false. The universe is most definitely not random. All right, so superdeterminism means that everything that happens in the universe is predetermined to happen based on the initial correlations of the universe created at the Big Bang. So, at the creation of the universe, what the universe was at its first appearance in time, the the subsequent correlations that you might see occur in the universe were all preset at the moment of the creation of the universe. So correlation means that there's a mutual relationship or connection between two or more things. So those connections were first made when the universe first began to exist. So those connections already existed. They may not appear until much later in the universe's history, but they were there with the initial correlations of the universe when it first came into existence. That's what I mean by initial correlations. So everything that happens in the universe is fated to happen. You can't change the future, nor can you know the future. With exactitude, with 100% absolute exactitude. That's one of the consequences of a predetermined future is you can't change it. So you can't know the future with 100% exactitude because then you could change that future, which you can't change because it's predetermined. It would be logically impossible for you to change a predetermined future. Now, there might be an exception for knowing about a future which you can't change. But that would be the only exception. And in that case, you would know about a future, but you couldn't change the future. So it wouldn't change a predetermined future. So you wouldn't get into this illogical conundrum of being able to change that which cannot be changed. All right, so the future is predetermined. You can't change it. Would I sweat too much about this? No, because life is exactly the same as it was 2 minutes ago before you knew that the universe was superdeterministic and predetermined. Nothing's changed. You can't know the future with 100% exactitude anyway. So, as far as you're concerned, the future is still unknown to you. It still appears to be random. In some instances, it still appears to be uncertain to you. So nothing's changed because your knowledge isn't any greater than it was before. But as far as the universe is concerned, the universe knows exactly what's going to happen to you. You don't, but the universe does. Now, some people really hate the idea of superdeterminism. And the reason is because they think it denies free will. But the truth is, what is free will? Free from what? When you say I have free will, then you assume that you're saying that you're free from something, right? So what are you free from when you say you have free will? Um, and the only answer that makes any sense at all would be to say, well, I'm free of anything that could influence me. But that would mean you'd have to be free from the laws of physics themselves. And you can't be free from the laws of physics because you're in the universe. Everything in the universe is subject to the laws of physics. So, in this sense, how are you ever free from the laws of physics, regardless of what you think the universe is or isn't? So, regardless of whether you think the universe is superdeterministic or whether you think it's random, you're never free from the laws of physics. And if you think the universe is random, then what does free will mean? Does that just mean your choices are randomly selected? How is that free in any sense of the word? If you don't know your choice and your choice is essentially chosen by the roll of the cosmic die, you still have to follow whatever the result is on the die. That doesn't mean you're free. So, this objection to superdeterminism about free will is a red herring. It's a total red herring. You have the same problem justifying free will under any sort of regimen of laws of physics that you choose, because you can't avoid the laws of physics. So this is a big red herring. And indeed, the only thing that really has free will is God, because God is not subject to the laws of physics. God is outside space time itself. So, if you believe in free will, you better believe in God, because only God can give you free will. Okay, now I'm going to talk about, all right, well, how do we know that the universe is super deterministic? Because obviously, this is going to be news to you, because just about nobody knows this. So I'm going to explain to you why it is that we know that the universe is super deterministic, even though 99.9% of people have never heard of superdeterminism and don't know this fact. So Uh, Superdeterminism, the idea of superdeterminism, has been around since 1985 when Dr. John Bell suggested it as a possible solution to Bell's inequalities. It's a possible solution to the problem of quantum entanglement. However, in 2020, a Swedish physicist named Johan Hansen presented a proof as to why the universe is in fact superdeterministic. And if you understand the proof, you understand how good it really is. And he really does prove that the universe is superdeterministic. So it's really been until just recently, the last year, that superdeterminism is really taking off as a credible theory of physics. Prior to that, it was people didn't like it because of the free will issue, and they didn't like the fact that it would undermine the statistical independence of scientific experiments. But Dr. Bell suggested it himself as a possibility, and now Dr. Hansen has proven it is true. So whether you like it or not doesn't matter, because your opinion isn't going to change his proof. The proof is what it is, and it's excellent. So that's what I'm going to talk to you about, what this proof is. So his name is Dr. Johan Hansen. And his proof is entitled Bell's Theorem and Its Tests. Proof that nature is superdeterministic, not random. And it appears in the journal Physics Essays, volume 33, published May 22nd, 2020, at pages 216 to 218. So if I were you, I would Google that up and check out his brief paper on this proof. It's excellent. Difficult to understand for lay people who don't understand the physics involved in it, but if you try hard enough, hopefully you'll be able to figure out exactly what it is he's saying, and you'll be able to be amazed by his proof that the universe is superdeterministic. All right, so here's the name of the proof, the article, and the journal. All right, so his proof is actually quite simple, but you have to understand something about quantum entanglement and Einstein's special theory of relativity, more specifically, the relativity of simultaneity. Now, the relativity of simultaneity is a very difficult concept to wrap your head around. So it's going to take you quite a while to understand it. However, Einstein's relativity is the greatest physics theory, the most confirmed physics theory of all time. It is the best theory going, and uh, this proof by Hansen uses Einstein's theory to prove that the universe is superdeterministic. So you really can't get a better proof than this. Einstein has never been wrong, never. Now, true, this is a theoretical proof, not an experimental proof. No one's actually ever perform this experiment to prove this. But because Einstein's theory, special theory of relativity, is so well known, you can simply apply it to quantum entanglement and know that this is true. So it's a theoretical proof, but that's good enough because Einstein's theory no one has ever found a flaw in it, ever. All right, so moreover, this proof involves quantum entanglement, and quantum entanglement involves particles at the quantum level. So it applies to the micro scale of physical reality. So all those naysayers who want to say, well, quantum mechanics says that the universe is random, they're wrong, because this involves particles at the quantum level. So it's telling you what is the truth at the quantum level. And the truth is the universe is superdeterministic. Okay, so you have to understand what quantum entanglement is. And quantum entanglement is a phenomenon, a real phenomenon that occurs when two particles, like say photons, are put in an entangled state. That means they're connected with one another. So what this means is that there's a correlation between these two particles that there ordinarily wouldn't be. So let's say you take a photon, which is a particle of light, and you measure its spin. Now, its spin could be either clockwise or counterclockwise, but under quantum mechanics, whatever its spin happens to be when you measure it, it's completely random. You have no way of knowing in advance which spin it's going to be. So it's a 50-50 deal. It's either going to be clockwise or counterclockwise, 50-50 chance. You don't know. But when you take two photons and you entangle them and you measure the spin of one, you know that when you measure the spin of the other one, it's going to be exactly the opposite. So if you measure the first one and it's clockwise, you know, even though you haven't measured it yet, you know that when you do measure it, the spin of the second one is going to be counterclockwise. So there's an absolute correlation between the measurements between two photons that are entangled. And this is a great mystery in physics, because you can take two entangled particles and separate them in time and space, a galaxy apart. And if you measure one before the other one, you will always know what the measurement of the second one will be, regardless of how far apart in space and time they are. So the question becomes, well, how does the second one know what to be when it's measured? Because how does it know what the first one was? How does it know? You'd think, well, I got the second one saying, well, I got to be the exact opposite spin of whatever the first one is. So you got to know what the first one is, right? So how does the second one know what the measurement of the first one is? If they're spread a galaxy apart, there's no way that the first photon can communicate to the second photon to tell it what its spin should be, because communications can only go at the speed of light. And these particles are so far apart that light cannot possibly reach the second photon in time to tell it what spin it should be when you measure it. So the question is, well, how does the second one know what to be? And the answer is, it's all predetermined. It's predetermined by the beginnings of the universe. The initial correlations at the beginning of the universe have already determined that this experiment was going to occur. And it has already determined that these spins will be just the opposite of one another, regardless of how far apart they are in space and time. So it's all predetermined. That explains how this one knows. It knows because it was told at the beginning of the universe what to be. Didn't have to wait for this one to tell it what to be. It already knew what it was going to be. That's the superdeterministic explanation to quantum entanglement. Now, if you apply Einstein's special theory of relativity to the typical quantum entanglement experiment, you'll realize that the universe has to be superdeterministic. It's one thing to say, well, superdeterminism explains quantum entanglement, it's another thing to prove that that has to be the case. And that's what Dr. Hansen did. So let's take the simple quantum entanglement experiment, and then I'll show you what happens when you apply the relativity of simultaneity, and you'll see. So imagine a simple experimental setup where you have a table and an observer sitting in the middle of the table. And on each end of the table, you have a device that is capable of measuring the spin of entangled photons. So you have your observer in the middle, and then you have a device that can measure an entangled photon. All right, so let's say you take two entangled photons, you put one in each of these measuring devices, you're sitting in the middle, and you measure them simultaneously. You will find that there's an exact correlation in their spins. So if photon A has a clockwise spin, photon B will have a counterclockwise spin. If photon B has a clockwise spin, photon A will have a counterclockwise spin. They are perfectly correlated to be exact opposites. Now, imagine this quantum entanglement experiment observed from different relative frames of reference. This is a term that Einstein uses regarding relativity. So imagine there's two people observing this experiment occur as it occurs. But those two people are going past the table near the speed of light in their own relative frames of reference, but in opposite directions. So, for instance, you have one observer going this way past the table near the speed of light, and he's watching the experiment occur. And then you have another guy going in the opposite direction. And he's also going near the speed of light, and he's watching what happens on the table, but he's going in the opposite direction of the table. So what happens under the relativity of simultaneity is these two guys see the events, the sequence of events that occur on the table in a different order than each other and the guy who's actually observing it, or the guy who's at the table. The guy at the table sees these two events. The two measurements of the two photons occur simultaneously. They happen at the same time for him. But for this guy traveling in this direction at the speed of light, he sees this measurement first before this one. And that's due to the relativity of simultaneity. You can Google that if you want and look it up. And I know it's very difficult to understand, but trust me, this is basic relativity. Relativity of simultaneity. So this guy going in this direction sees A measured before B. Now this guy going in the opposite direction, he sees B measured before A. So these guys see different events occurring at the table. One sees photon A measured before B, and the other one sees photon B measured before A. Now that's true. I know that's hard to wrap your mind around, but it's absolutely true. So what does this mean? Well, if the measurements were random and they were actually caused by the measurements, what you would expect is if photon A is measured before photon B, you would expect that the the spin measurement for A would be random. So it's either going to be clockwise or counterclockwise, but it's a 50-50 deal. You don't know. But whatever that measurement is, it absolutely determines the measurement of photon B. So if photon A is measured clockwise, photon B is going to be measured counterclockwise. So the result is 50-50. Same thing with the other guy who sees photon B measured before photon A. So he sees photon B measured first. So whatever that measurement's going to be, clockwise or counterclockwise, it's a 50-50 chance, a random chance. So the resulting correlated measurement of photon A, the subsequent measurement, is also going to be a random chance, 50-50. It's going to depend on what this one is. So the problem is, from these two observers, one sees one measured before the other. There can't be a correlation in results because each one has a 50-50 chance of having clockwise or counterclockwise spin. So it would have to be random. So there couldn't be a correlation in the results of the measurements of these two photons, depending on what frame of reference you happen to be observing the experiment. But the truth is that the results are correlated. We know this. This is what happens in quantum entanglement. So how do you explain this correlation in results, even though, depending on your frame of reference, the results under quantum mechanics shouldn't be correlated? So what's going on here? The answer is it's predetermined. The truth is, when this guy sees photon A measured before photon B, the result of the measurement of photon B is already predetermined. So it's not as if the measurement of photon A is actually causing the measurement of photon B. It's not. It's not really a 50-50 deal. It's already predetermined. It may appear to be a 50-50 deal or random. It may give the appearance of random, but it's a predetermined appearance of randomness. So there is no actual causation going on. The measurement of photon A before photon B, this measurement of A, doesn't actually cause photon B to be measured in the exact opposite spin. It's not actually causing it to happen. So what Dr. Dr. Hansen has proved is that causation is not real. Temporal causation, that is, causation in time, is not real. It's not a real thing. Everything is following a predetermined script. You can't change anything, so you can't cause it to be changed because you can't change it. So superdeterminism proves that temporal causation is not a real thing. That's a big deal to claim that things aren't actually caused by other things. They're just following a script. That's really mind-blowing, isn't it? But it's also true. What does this mean? This means that the universe isn't random. It's not. It's following a predetermined script. That's the only way you can explain what's going on here, is that temporal causation isn't real and the universe is simply following a script, a predetermined script, and that's why the results are still correlated regardless of what frame of reference you happen to be in and what direction you're going towards or from the basic quantum entanglement experiment. And you know, the quantum entanglement experiment involves very small particles. Well, the large structures of the universe are made of these small particles. So what's good for the small particles is obviously good for the large particles. So you can assume that the entire universe is superdeterministic because its smallest parts are superdeterministic. And the largest parts are made of those smaller parts. So obviously the larger parts would also have to be superdeterministic. And the quantum entanglement experiment has been shown in photons, in electrons, in neutrinos, in molecules, and even in small diamonds. So it has gone across a range of particles. So you can apply this principle to the entire universe. The entire universe is superdeterministic. Okay, so you now understand that the future is set and predetermined, and you can't change it, and the universe is superdeterministic. So, what are the consequences? The consequences are enormous, enormous. The first, number one consequence is the realization that the universe is not random. Um, Although it may give the appearance of randomness. That appearance of randomness is really predetermined. It's a predetermined appearance of randomness. It's not truly random. The universe is not random. So if people tell you that the universe is random or that the universe is created by chaos and from chaos comes order, they're all wrong. And you can tell them that Dr. Hansen proves that you're wrong. So stop saying that because it's not true. The another consequence is that because the universe is predetermined, then something had to predetermine it. You can't have a whole history of the universe, a whole script created that the universe has to follow, without something that creates that script. Something had to predetermine the universe, and that thing is God. So superdeterminism proves the existence of God because something has to be outside the universe capable of predetermining that universe. And that also means that every one of us is part of God's plan. And God really does have a plan for the universe. And it's a super deterministic plan. Another important consequence of superdeterminism is that it proves that an infinite multiverse is impossible. Now, how's it do that? Well, because superdeterminism relies on the initial correlations established at the Big Bang to essentially create the script for the entire universe, then that would mean that if a universe were infinite, infinite in size or infinite in duration, then that script would also have to be infinite. But that's impossible because an infinite script or infinite correlations would require infinite information to contain the history of that universe as it evolves through time. But it can't contain infinite information because when you get to a certain smallness in the universe, you can't get any smaller. And anything smaller is meaningless. So it can't contain infinite information because there's a limit to how much information you can compress into the universe. This is called the Planck scale problem. And you can Google that and research that yourself. Anything smaller than the Planck scale is meaningless. It doesn't have any meaning. And if it doesn't have any meaning, it can't contain the information necessary to have a predetermined universe unfold. So the Planck scale problem proves that an initial correlation has to be finite in terms of how much information it can contain, which means that the universe can only exist for a certain period of time until that information runs out. So a universe has to have a discrete beginning and it will end. The universe ends like a ball of yarn unwinds. Eventually, the end of the yarn is met and the universe disappears because the amount of information has ended. Um, so a superdeterministic universe has to have initial correlations, the beginning of that universe. So that means the universe has to have a beginning, which means something has to cause the universe to begin, which means you have to have a God to cause the universe to begin. Um, so you can't have an infinite universe, infinitely large or infinitely long-lasting universe, because that would require, first off, an infinite universe that, let's say, never began, would never have initial correlations. So it can't possibly be the case because superdeterminism requires initial correlation. So you can't have an eternal universe. And even if you did, you would still need infinite information in those correlations in order to have a perpetually existing eternal universe, which you can't have because you can't have infinite information in the initial correlations because you can't have that infinite density of information due to the Planck scale problem. What this means is there can't be an infinite multiverse. Can't happen. Um, Finally, another significant consequence. There are a lot of consequences to superdeterminism. I haven't hit upon all of them. I'm just giving you the biggies. Another consequence is that superdeterminism disproves the Copenhagen interpretation. So there's this thing called the Copenhagen interpretation of quantum mechanics. It's essentially how physicist Niels Bohr thought about quantum mechanics, and the idea is that the universe is random, that it's indeterminate, that you can't know with exactitude what the universe is going to do, even though it seems to act within a defined probability function or distribution. But it's essentially saying the universe is random. Well, guess what? Niels Bohr was wrong. The universe only appears to be random, but the truth is it's not. It's predetermined. It's a predetermined appearance of randomness, not actual randomness. So the Copenhagen interpretation, which has been a very long-standing interpretation of physics, is falsified because of superdeterminism. And this is a big deal, very big deal. There are many, many people who, for over a century, have thought that the universe was completely random. And some people thought that that was proof that God didn't exist because even God wouldn't know what the universe was going to do because it was random. So, how could there be a God directing it? So, the truth is, this is false. Superdeterminism is true. And you do need a God to predetermine what happens in the universe. Well, that's my quick explanation of superdeterminism, uh, and research it yourself. Um, and there's more details involved in this than I could go through in only a half hour. But trust me, Dr. Hansen has really put forth a great proof, and you should believe that the universe is superdeterministic. So if somebody tells you the universe is random, tell them, no, you're wrong. It's actually predetermined. And read this proof and you'll understand why. Okay, I hope you enjoyed that. And this is very important stuff. You should know this. And take care, everybody.